Hi students, good morning. In this class we will discuss two new chapter number 9, differential calculus, limits and continuity. Already we know that the calculus, what is meant by calculus? Calculus is the mathematics of ratio of change of quantity. Okay, ratio of change of quantity is called the calculus. Okay, the calculus using in various field. For example, using in physics lab and chemistry, find some numerical value in statistics and etc. Okay, here the calculus means the ratio of change of quantity. Okay, limits and continuity. What is meant by limits? For example, assume one function, that is f of x. The f of x function of x, substitute x values, we get the value of the function. Okay, value of the function. Substitute the values of x in all are in distinct means we have the value all are in distinct value, isn't it? Yes. Suppose we assume one function f of x, x tends to 5 or some constant, any one constant, that is real numbers. Any one constant we get the some values, that is the limit of the given function. Okay, and continuity. What is meant by continuity? The function is draw the function or identify in limits using the principle of limits. Continuity means the graph is entirely non-break. Okay, non-break, that is discontinuity is called the continuity. Okay, is called the continuity. Okay, here let's go to the limits. Okay, here calculus is the ratio of change of quantities. Okay, calculus is a limit machine. Okay, involves 3 stages. In the first stages, pre-calculus. In the second stages, limit process. Okay, limit process. And the third stages, calculus. Okay, in the definition 9.1, the first definition, let I be an open interval for all x naught belongs to capital R. It means capital R means real numbers. Okay, real numbers. Minus infinity to plus infinity. Okay, the function f of x be a function such that interval I tends to capital R. Okay, tends to capital R. The limit of the function f of x is L. Okay, f of x exists is L. Okay, if whenever x approaches to x naught from either side means both sides, that is right side or left side. Okay, then f of x approaches, f of x becomes sufficient to L, that is called the f of x is L, that is called the limit. Okay, here it is denoted by limit x tends to x naught. X tends to x naught, it means x approaches to x naught, the function is approaches to L. Okay, this is the limit, definition of the limit. Okay, here definition 9.2, left hand limit. Okay, what is mean by left hand limit? Okay, what is mean by left hand limit? Okay, x approaches x naught from the left. Okay, from the left is called the left hand limit. It is denoted by x naught power, putting the sign is minus. It is represent to x approaches x naught from left. Okay, from left. F of x naught minus is called the approaches left side. Okay, approaches from left, which is equal to limit x tends to x naught minus f of x, which is equal to some limit. Okay, some limit, that is L. Okay, here for example f of x, which is equal to 3x minus 5. Okay, 3x minus 5. Here here x approaches 5, okay, x approaches 5. Here x approaches 5 minus means 5 minus power, putting the sign in power, okay, in power. 5 minus means don't consider to minus 5, okay, don't consider to minus 5. X equal to minus 5 is wrong, okay, is wrong. Here substitute x equal to 5, the sign represent to approaches from the left side, okay, the sign approaches from the left side, that is 3x minus 5. Here substitute x equal to 5, 3 into 5, 15 minus 5, which is equal to 10, okay, is equal to 10. This is the important one. X tends to 5 power minus means don't consider x equal to minus 5, okay. Here the sign represented x approaches to 5 from the left side, okay, from the left side. In real numbers, here the 5, okay, x approaches left side means x approaches left side, that is the sign, okay, that is represent to the sign, okay. Next go to definition 9.3, right hand limit, okay. Here x approaches x naught from the right side, okay, from the right side, that is x naught greater than x, okay, that is x naught greater than x. Here it is denoted by x naught power, the sign have plus, okay, the sign have plus is the right hand limit, okay. It is denoted by limit f of x naught power plus, which is equal to limit x tends to x naught power plus, that is x approaches to x naught from the right side, okay, f of x, which is equal to n, which is equal to n. Next, how to identify given function have limit exists or does not exist. We have three steps. We are following three steps. It means hold three stages. The first one is limit x tends to x naught plus means x approaches to x naught from right side, okay. F of x, the value is exists, okay, the value is exists. Next go to the second condition. Suppose the value does not exist means the given function does not exist, okay, does not exist. The value exists means go to the second stage, limit x tends to x naught minus means x approaches to x naught from left side, okay, from left side. F of x exists means go to the third stage, okay. Suppose second stage does not exist means therefore the given function does not exist, okay. Then the third one, both values are equal, it means x approaches to x naught from right side and left side are have the same value, that is unique real number. Unique means same, okay, unique means only one value, that is same value. Therefore the given function have limits or exists. Suppose the above conditions, if any one of the above conditions are does not satisfied, are not satisfied means therefore the given functions does not exist, okay, does not exist. Now in figure, how to identify the given function have limit exists or doesn't exist using figure, okay. Example, now we take 4 types of figure, okay. In the first one, in 2 dimensional, that is x axis, y axis, this is the given curve, that is f of x in particular point, okay, x approaches to x naught, here this is n left side approaches x naught from the left side, okay, from the left side. Here x approaches x naught from the right side, okay, this is the from the right side, this is left side, okay, this is left side, okay. Here in the particular point x9, okay, check in the particular point x naught. Here the curve is um, meet in x naught in same value. Okay, in same value means single value. Therefore the given function exits the limit. Okay, exits some limits. Therefore limit x approaches x naught, f of x exits. F of x exits because x approaches f x naught in from left side and right side, meeting in only one point, meeting in only one point. Therefore f of x exits. Okay, here in another one figure, x approaches to x naught in from left side. Okay, this is left side. X approaches to x naught from right side, meet in single point. Okay, meet in single point, that is particular point, that is x naught. Okay, here meet in single point. Therefore the f of x, limit x tends to x naught, f of x exits. Okay, f of x exits. Now we take the third one. Here x axis, y axis, this is origin, this is an x naught. Okay, this is a particular point, x approaches to x naught from left side have some limit, from left side have some value. Okay, and find another one is x approaches x naught from right side. Both values are distinct. Both values are distinct means here this is a left point, this is a right point. Both are distinct means two different values. Therefore limit x tends to x naught minus means x approaches x naught from the left side, that is f of x is not equal to limit x tends to x naught plus f of x. Okay, plus f of x. Therefore f of x does not exist. Okay, f of x does not exist. Okay, in the last one here, only define the function from the right side. Okay, x approaches x naught from the right side, only define the given function. In the left side does not exist. Okay, that means is not defined from the left side. Okay, x approaches to x naught from the left side is not defined. Therefore f of x, that is limit x tends to x naught, f of x does not exist. Okay, does not exist. Next we will discuss some illustration, that is some standard result. Illustration 9.1. Let y equal to f of x equal to x squared plus 3 be an algebraic function. Okay, it is an algebraic function. Here x equal to, substitute 1 squared 1 plus 3 which is equal to 4, isn't it? 1, that is 4. Substitute 2 means 2 squared is 4, 4 plus 3 is 7, 2. Sorry, in the diagrams some corrections. Diagrams are some corrections. Okay, okay, here x equal to, now consider in one point x approaches to x naught. Okay, x approaches to x naught. The x naught is now consider to 2. Okay, now consider 2. Okay, that is here x, substitute x equal to 2 means, the value of y, that is f of x is 7. Okay, that is f of x equal to 7. Okay, here limit x tends to 2, f of x. F of x is x squared plus 3. It is 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. Okay, 4 plus 3 is 7. Now calculate to left approaches, that is x naught minus. Okay, that is limit x tends to 2 minus means don't take x, substitute x equal to minus 2 is an error. Okay, here the sign represented to x approaches to from the left side. Okay, from the left side, f of x which is equal to 2 square plus 3, it is 7. Okay, next find right approaches, that is x tends to 2, x approaches to the sign plus represented to x approaches to from the right side. Okay, f of x which is equal to 2 square plus 3 which is equal to 7. Here in the first one limit exits, the second one left limit, right limit, then the values of these are unique. These are unique real number. Unique means same. Therefore the given function limits are exits. Okay, given functions limits are exits. Therefore f of x limits are exits. Is exits. Okay, is exits. Okay, in the second illustration, let y equal to f of x equal to 16 minus x square divided by 4 plus x. Okay, this is an rational function. What is mean by rational function? Rational function means p of x divided by q of x. Okay, p of x divided by q of x. This is called the rational function. Okay, here the function is not defined at x equal to minus 4. Okay, substitute x equal to minus 4 means minus 4 the whole square is plus 16. 16 minus 16 divided by 4 minus 4. 0 divided by 0. Okay, 0 divided by 0. Denominator have 0 means goes to infinity. Okay, goes to infinity. That is the function is not defined at x equal to minus 4. Okay, the domain of the function, domain of the function is real numbers. Okay, is real numbers except minus 4. Okay, except minus 4. This is the domain of the given function. Okay, given function. Now simplify the given function f of x which is equal to here 16 can be written as 4 square. Okay, 4 square minus x square. 4 square minus x square divided by 4 plus x. Okay, which can be written as 4 plus x into 4 minus x divided by 4 plus x. Here 4 plus x factor are cancelled, then the remaining result is 4 minus x. Okay, 4 minus x. Here to find the left limit, that is limit x tends to 4 minus. Okay, x tends to 4 minus. Okay, x tends to 4 minus means 4. Now consider x tends to minus 4. Okay, substitute x tends to minus 4 left. Okay, here f of x is 4 minus x. F of x, that is 4 minus 4. Minus of minus plus 4 plus 4 is 8. Okay, 4 plus 4 is 8. Limit x tends to minus 4 plus means x approaches minus 4 from the right side. Okay, from the right side. F of x which is equal to 4 minus 4, that is 8. Okay, that is 8. We conclude the given function limits does not exit. Okay, does not exit at x equal to minus 4. Okay, at x equal to minus 4. Suppose x approaches to minus 4, f of x have some limits. Okay, f of x have some limits, that is f of x exits. X approaches minus 4 means the given function exits. Okay, exits. Suppose x equal to minus 4 means the given function, that is f of x, does not exit. Okay, does not exit. In statement here, x approaches x naught, that is near to minus 4. Okay, both either side. Okay, x approaches x naught near to minus 4 means f of x limits are exits. F of x are exits. Okay, are exits. Suppose x approaches x naught, that is reach to x naught. Okay, reach to minus 4, that is equal to minus 4, that is x naught equal to minus 4 means therefore f of x does not exit. Okay, does not exist. Okay, does not exist. Next, go to one more illustration, 9.3. Let f of x equal to, then the numerator have absolute value function. Okay, this is called absolute value function. Then the denominator have factor x. Okay, f of x equal to absolute values of x divided by x. Okay, here the domain of the given function, the domain of the given function. Okay, given function is real numbers. Okay, capital R, that is real numbers except 0. Okay, except 0. Now we are check into x not equal to 0, the function limits exits or does not exit. Okay, here limit x tends to 0 minus, it means x approaches to 0 from left side. Okay, from left side of f of x, which is equal to here from left side means here absolute value function factor means equal to 0. Okay, factor means equal to 0. Okay, here using real numbers x equal to 0, plotting the real numbers 0, minus infinity, plus infinity. Okay, now we check x equal to 0. Okay, x equal to 0, minus means approaches left side. Okay, approaches left side. Here we take minus x. Okay, minus x divided by plus x, that is x are cancelled, x are cancelled, the value is minus 1. Okay, then the value is minus 1. Here next to find limit x tends to 0 plus. Okay, 0 plus means f of x, which is equal to here 0 plus means x approaches to 0 from the right side. Okay, from the right side. Now we take the factor plus x divided by x. X are cancelled, that is the value is plus 1. Okay, the value is plus 1. Here f of x naught minus, which is not equal to f of x naught plus. Okay, x naught plus. Therefore the given function f of x does not exit. Okay, does not exist. Does not exits. Okay, in the same function we take in the same function and check into the another value. Okay, check into the another value. Suppose x approaches minus 3. Okay, approaches minus 3. Okay, it means here minus 3, 0, plus infinity, here minus infinity. Okay, here minus infinity. Absolute value function, that is modulus of x means then the graph like is similar type. Okay, in the graph like these types. Okay, here x approaches minus 3 means limit x tends to minus 3 minus f of x, which is equal to here x approaches minus 3 is left side to 0. Okay, left side to 0. So we take the function minus x divided by x, which is equal to minus 1. Okay, next find limit x tends to plus minus 3. The sign is plus means f of x, which is equal to here, listen, x approaches minus 3 from the right side. Okay, from the right side the minus 3 is to the left of 0, isn't it? The left of 0, that is negative values. Minus 3 lies negative values, isn't it? Yes, therefore the function minus plus we take same value, same factor minus x divided by plus x, which is equal to minus 1, because the minus 3 lies less than 0, that is negative value. Minus 3 lies in negative value. Therefore the factor minus x divided by x and minus x divided by x, that is minus 1 equal to minus 1. Therefore the given function is function f of x. Limits are f of x are exits. Okay, f of x are exits. Okay, in another we conclude another one value, that is x approaches just plus 5. Okay, x approaches plus 5. Here 0 plus 5. Okay, minus infinity plus infinity. Limit x tends to 5. Minus means x approaches 5 from the left side. Okay, from the left side. Okay, the 5 is greater than 0, isn't it? 5 greater than 0, that is 5 lies in positive side. So we take the factor plus x divided by x, which is equal to plus 1. Okay, limit x tends to 5 plus f of x, which is equal to plus 5 means x approaches 5 from the right side. The 5 lies in positive side, that is greater than 0. So the factor is plus x divided by x, which is equal to 1. Both values are same means, therefore f of x are exits at the x equal to 5, at the x equal to minus 3, but f of x does not exist at x equal to 0. Okay, x equal to 0. In one more additional conclude is, conclude for any real number, that is x naught less than 0. Okay, x naught less than 0, that is the function f of x, which is equal to modulus of x divided by plus x, which is equal to, we take the final result is minus 1. Okay, that is minus x divided by x. X approaches x naught, that is x naught less than 0 means negative value. Okay, negative value means minus x divided by x, that is minus 1. Okay, suppose x naught greater than 0. Greater than 0 means x naught lies in positive side, that is f of x, which is equal to modulus of x divided by x, which is equal to plus x divided by x, which is equal to plus 1. Okay, which is equal to plus 1. Okay, here x naught equal to 0 means, okay, x naught equal to 0 means f of x naught plus, which is not equal to f of x naught minus. Okay, f of x naught minus, both are not equal, therefore f of x does not exist. X does not exists at x naught equal to 0. Here in left and right approaches are same value, limits are exits. Okay, limits are exits at the x naught less than 0. Here limits are exits at the x naught greater than 0, but x naught equal to 0 means limit does not exist. Okay, next go to one more. X approaches for any integer. Okay, x approaches for any integer. Okay, any integer, that is n. Okay, here the function, let f of x be a function that is greatest integer function. Okay, which is called the greatest integer function. Okay, now limit x tends to n, that is x approaches to n, minus means from the left side. Okay, from the left side the greatest integer function like as previous value. Okay, previous value, that is n minus 1. Okay, that is n minus 1. Suppose next find to the right approaches right value, that is limit x tends to n plus means then the greatest integer function which is equal to n means n. Okay, n plus means approaches from the right side, n means n minus means from the left side means previous value, that is n minus 1. Okay, kindly note it.